Number 8. Figure 1 shows the plan view of a stage. The plan view shows two congruent triangles ABO and GFO joined to a sector OCDEO of a circle center O, where angle COE is equal to 2.3 radians, arc length CDE is equal to 27.6 meters, AOG is a straight line of length 15 meters. Part A, show that OC is equal to 12 meters. So for part A, we are told that arc length CDE is equal to 27.6, and we know that arc length is given by radius theta when the angle given is in radians. So if we substitute what we know for this equation, the arc length is 27.6. We're looking for the radius, so we can just write that as r, and the angle is 2.3 radians, which means that to find r, we will do 27.6 divided by 2.3, and this gives us 12 meters. Part B says that show that the size of angle AOB is 0.421 radians, correct to 3 decimal places. So for part B, we know that this is a straight line angle, which is equal to pi radians. And we know that the two triangles ABO and GFO are congruent, which means that this angle here is going to be the same as this angle here. Therefore, for part B, we are going to do the straight line angle, which is pi, take away the 2.3 radians, and divide this by 2 in order to find angle AOB. And when we do this, we have to make sure that the calculator is in radians, and if we work this out, we will get an answer of 0.421. The next part of the question says, given that the total length of the front stage, BCDEF, is 35 meters, part C says find the total area of the stage, giving your answer to the nearest square meter. So the information that we've been given is that BCDEF is 35 meters, which is this whole length here. And therefore for part C, in order to find the total area of the stage, we are first going to have to find the area of triangle AOB, then add it to the area of triangle OFG, and then add it to the area of the sector OCE. However, because triangle AOB and OFG are congruent, we can just find the area of one triangle and then multiply it by 2, and then add on the sector area. So first, in order to find the area of triangle AOB, we know that this angle here is 0.421 radians like we found in part B. And in order to find this area, we would need both these sides so that we can use the formula a half AB sine C. In the diagram, we can see that the length AG is 15 meters. So in order to find the length AO, we can just half it. We can just half the 15, and this will give us 7.5 for each side. Therefore, the length AO is 7.5 meters. In order to find the length OB, we know that OB is made up of two line segments, which are OC and CB. We already know OC is the length of the radius, which is 12, but we do not know what CB is. However, using the information that was given about the length of the front of stage being 35 meters, we can use that to help us find the length CB. The front of the stage is made up of BC plus CE plus EF, and the total of these should equal to 35. We know that BC is going to be exactly the same as EF, so we can write this as 2 times BC. We know that the length of CE is 27.6, which is the arc length, and this should be equal to 35. In order to find BC, we are therefore going to do 35, take away the 26.2, and then divide this by 2. And if we work this out in the calculators, we will find that BC is equal to 3.7 meters. We can now use this length in order to find the length OB. So if we substitute this, we can write 12 plus 3.7, and this gives us 15.7. So the length OB is 15.7, and we can label that on the triangle here. And therefore, in order to find the area of triangle AOB, we now have all the lengths and the angle that we need. So we can just substitute it in the formula a half AB sine C. So we will do a half multiplied by 7.5 multiplied by 15.7 sine 0.421. We again have to make sure that the calculator is in radians before we work this out on the calculator. And if we do that, this will give us an answer of 24.06. We now need to find the area of the sector OCE. And in order to do that, we are going to do a half radius squared multiplied by the angle. So we're going to do a half multiplied by 12 squared and the angle 2.3 radians. And again, if we put this in the calculator, we should get an answer of 165.6. We now have the triangle area, which is 24.06. And we now have the sector area, which is 165.6. So in order to find the total area of the stage, we are going to do 2 times the area of one triangle, which is 24.06, and we are going to add 165.6, and this gives us a total area of 214 meters, rounded to the nearest square meter.